Okay, so let's start with the table over here. We've got the different base quantities. We've got the SI units and their symbols. Okay, take note of the differences between SI units and symbol. SI unit in this case will be the name. The full name, which you need to know how to spell. Whereas the symbol is just one letter or two letters to represent the unit. Because we don't like to spell everything out every time we do our working, right? We have that habit since primary school already. So these are the short forms, the symbols. Okay, have you already memorized all the SI units? Yes, okay. How many are there? 7 of them, right? And some are very frequently used in our syllabus. In the first 3, especially important. Okay? So let me just do a quick check. What is the SI unit for mass? You cannot tell me kg. Kg is the symbol. What do you have to say? What is the SI unit for mass? Kilogram, yes. What is the SI unit for time? Yes, seconds. What is the SI unit for length? Meters. Okay, very good. So for the rest of the other 4, please go and find them out yourself. Okay, now SI unit for area. Okay, that's interesting. We've only been talking about the unit for length, right? For time, for mass, current, temperature, so on and so forth. But what about area? How do we decide? So what do you think is the answer over here? A, B, C, or D? C. Why? Why do you think C is the answer? You see, in physics, whatever answer that you are giving me, you should be able to explain why. Area is? What do you mean by area is meters times meters? Let's be a little more specific. Okay, area of a square is given by length times breadth. Area of a rectangle is given by length times breadth. It is always length and breadth for this type of squares or rectangles, right? Even for a triangle. Let me just put out some examples for area of square rectangle is length times breadth. For triangle, what is the formula that you have learned? Half times base times height. What about for circle? Height R times R, right? Okay, let's take a look at all these things over here. We know that length and breadth over here, what are the units? What's the unit for this one? Meter, right? So I've just put it up here, meters. Then for breadth, meters. Okay, I am specifically using SI units over here. Okay, I'm not using cm, I'm not using mm or kilometers. I'm using the SI unit for length. In this case, breadth also a measurement of length, right? So SI unit again will be meters. So if you take meters times meters, what do you get? Okay, so the SI unit for area of a square rectangle will therefore be square meters, because meters times meters will get a square meter. Okay, let's take a look for triangle. Does it work the same way? What's the unit for half? Is there a unit? It's just a number. Okay, it's just a number. There are no units over here. What about this base over here? Meter again. Okay. What about for this height over here? Meter again. Okay. No units times meters times meter. What do you think is the unit? The square meters again. Okay, and finally for last one, circle. Height is just a number. There are no units. Radius. What are the units? Meters again. For radius again, obviously meters again. So you see, in our calculation, we always use SI units, and we will result in the final units being square meters. Okay, so nothing else. And this is how we are going to be approaching all our workings when we are dealing with SI units. Okay? So for example, another question, if they are asking you to calculate the speed, and then they give you information, for example, the car is traveling at 60 kilometers per hour. Do you know how to convert this to the SI unit? What should the SI unit be in first place?
60 meters.
Let's ignore the magnitude first. Let's talk about the unit. What do you think the unit should be in SI unit? Meters per second. Right, so the answer over here will be C, square meters. Okay, next one. How many square centimeters are there in 1 square meter? Have you learned this in primary school also? No? Okay, then how should we do this question then? What do you think is the answer? 100. Anybody? 100? Okay. 10? Nobody chooses 10. 1,000. 10,000. Okay, looks like the more popular choices are 100 and 10,000. So how do we decide? Let me break down what square centimeter is and what a square meter is. Okay, let's take a look. What exactly is 1 square centimeter? So you may copy down these notes as well. 1 square centimeter is actually equals to 1 cm multiplied by 1 square centimeter is 1 cm multiplied by another 1 cm. Okay, are we all very familiar with this? Okay, what about 1 square meter? What is this exactly?
1 meter times.
Okay, very good. 1 meter times 1 meter. Any doubts about this? All very clear about this? Okay. What is 1 meter in centimeter? Because I want to convert square meters to square centimeters, right? So I want to convert 1 meter to centimeter. So how much will that be? 100 cm. Oh, I've got another 1 meter. So what should I multiply this by?
100 cm.
By again 100 centimeters. What do you think is my answer now? 10,000. And the units?
cm.
Units?
cm.
Are you sure cm? Square centimeters. How many steps did I use to convert 1 square meter to square centimeters? I converted it to meters first. I broke it down. Then I changed from meters to centimeters. Then after I just use simple mathematics, multiplication only. Okay? So answer will therefore be D. Alright? This method can always be used. Okay? For area, for volume. In the future, we'll be asking you, oh, how many cubic centimeters in 1 cubic meter? Then you can use the same approach to get your answer. So in this case, answer will be D. Alright? 10,000. Okay. Which one has the smallest mass? Okay, how do we decide? What exactly is mg? What does the m over there stand for? Meters? Milli. The m stands for milli. What exactly is a milli then? Okay, how much smaller?
10 times.
Okay, this milli over here simply means 1 over 1,000. Okay, just like a millimeter. 1 over 1,000 of a meter. So milli over here, the little m, is simply 1 over 1,000. So it is just, so 1 over 1,000 grams is very, very small, right? 1 gram already is very tiny. So 1 over 1,000 is much smaller, but this time we have 100 of them. Okay? So if I were to convert this to grams, I want to convert milligrams to grams. It is actually the same as 100 over here times 1 over 1,000 grams. This portion is known as milligrams. Okay, I'm trying to convert from milligrams to grams. So milligram is just 1 over 1,000 of a gram. 100 of it must therefore be equal to 1 over 10 grams. That is for part C. Now in part, option B, we've got 10 kilograms. How many grams is that? I want to convert everything to grams to compare.
10,000.
Okay, this will be, I'm going to use the same approach. I copy down the number over here, so this is 10. And then I've got kilo. How much is a kilo? Remember for milli, I said it is 1 over 1,000. What about for kilo? Kilo is 1000. Okay, yes? Oh, you mean your notes are different? Oh, it's milligram again. Okay, looks like my slides are, my options are different. So let me change this to your question. So you got 10,000 milligrams. Okay, so again, thank you. So no change to the approach, milligram. We're going to change this to grams. So we get 10,000 times 1 over 1,000 grams. Okay, 1 over 1,000 because milli. So if I work this out, I get 10 grams. That is for part B. Do you need me to go through part D with you? Option D? What is your D then? 10,000? 10,000 grams. Okay, so I think the answer is clear. The answer will be C. Okay. Okay, question 5. Which one has the largest area? So you see, when you have things in square centimeters, you have things in square meters, it becomes very difficult for us to compare. So we need to change everything to the same unit. Do you want to change to square meters or square centimeters? What do you prefer? Square centimeters? Okay. Is it because you don't like to work with many decimals? Let's take a look. Let us compare, convert 0.1 square meters to square centimeters. Do you remember the conversion? What is the conversion? 1 square meter equals to how many square centimeters? 100? Is it 100? All of you should be shaking your head because we just went through it a while ago. How much is that? Look at the previous question. How many square centimeters? Are you sure 100 square centimeters? Come on, you can do better than that. 10,000. Is this something that needs to be memorized? No, because you know how to work it out. I've shown you how to work it out. But if you think that you have too much space in your brain, you have too much energy, go and memorize. Go ahead. Nobody will stop you. Okay? For me, I don't like to memorize. I will work it out. And every time I work it out, I will practice. When I get a similar question, I can always do it again because I did not memorize. Right, so over here, this gives me 0.1 times 10,000 square centimeters, which is actually 1,000 square centimeters. Okay? Next one. 1 square meter, obviously this will be 10,000 square centimeters. So now it becomes easier for us to compare. Which is the largest area then? Class? D. 1 square meter. Oops. It looks like there's an error. It should be D. Okay? And taking a look at the 4 options. Which 2 areas are exactly the same? B and C, yeah, they are exactly the same, although the units are different. Okay, next. Which will you use to measure the diameter of a beaker? Okay, diameter of a beaker. So, have you all seen a beaker in primary school? Yes, I'm sure you have. So it's just like a cup. To measure the diameter, top view will look like this. It is a circle, right? In order to measure the diameter, your primary school maths tells you that diameter is the length from one side passing through the center to the other side, right? This is the diameter. When you look inside your cup, do you know where the center is? Exactly where the center is? You don't know, right? How are you going to measure the diameter then? You can't take a ruler and measure, right? Just measure the whole thing with a ruler. Divide. Okay, so take a look at this. Can I borrow a ruler? So over here I've got a ruler. I need to draw the circle, the cup smaller because the ruler is not too big. Okay, so suppose I have a beaker over here. Smaller circle. Okay, so this is my beaker over here. If I want to measure the diameter with a ruler, is this the diameter? How do you know?
Because it's passing through.
It's not passing through a center. Okay, how about this? No, how about this? Are you very sure? Can you ever be really sure with a ruler? Because? No, that's not good enough for physics. Must be really accurate. Then how? We can use vernier calipers because the ruler doesn't allow us to determine where the center is, right? So I need a vernier calipers. What does the vernier calipers have? The jaws, right? So I can use the vernier calipers I place here. I can slide the jaw up, then you measure this way. By the design of the vernier calipers, it allows us to measure the diameter very easily. Okay? So in this case, we will be using the vernier calipers. So answer over here will be D. Any questions? Okay, what do you think I should use if I want to measure the... Okay. If I want to measure the diameter of this wire, what should I use? Ruler? Vernier calipers? Okay, for the same reason, I can't use a ruler, right? I can't use a ruler to measure the diameter. I must use the vernier calipers with the jaws to clamp it. Okay? Subsequently, we will teach you another instrument that you can use to measure that. Okay, next. Now to obtain an accurate reading, we will be using the eye level from C. Okay, we've been through this last lesson already. And the error. There is an error if it takes the reading from D, from B, from A. Okay, no matter where it is from, A, B, or D, they are all wrong. And what is the reason? Parallax. You know, last year, when I was marking exam papers for lower sec, we had very similar question. Guess whether the students knew that this is called parallax error. Did they know? Most of them knew, no? Most of them knew. So do you know that it is called parallax error? Do you know? Can we say it together one time? Parallax, okay? 1, 2, 3. Parallax error. Now, very unfortunate. Your seniors, they knew that this is parallax error, but I marked them all wrong. Why? Because they don't know how to spell. Do you know how to spell? Know how to spell? Go and practice spelling. Make sure you get the spelling correct. How many L? How many A? Okay. Make sure you get it right. Okay. Complete the table with commonly used SI prefixes. Okay. Now, the first one I've shown you on the screen already. 10 to the power of 9. What exactly does 10 to the power of 9 mean?
10.
What is 10 to the power of 9? 10 times 10, how many times? 9 times. Is it a very big number?
Yes.
Okay, so this is 10 to the power of 9. 10 to the power of 9 simply means 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 10 to the power of 9. Can you imagine in your primary school mathematics, right? The problem sums involves such big numbers. And then you have to write so many times, right? Would you think you make a careless mistake? Is it better to write it this way? That about 9 is neater, isn't it? Okay, so this over here, this huge number, as a prefix, it is a prefix, it is called giga. And we use the symbol G, capital G, nothing else. Okay? Because what happens if we use a small g? Then what does it represent? Exactly, yes.
What's the meaning of giga?
The meaning of giga simply means 10 to the power of 9. Have you heard the word giga before? Yeah, you have, right? When do you hear gigabyte? Data. Okay, what are you talking about data? Storage, or for example, internet speeds, right? Okay, so your phone, how many gigabytes?
7.
Okay, let's just use 3 gigabytes. If a phone has, and they want to sell you, right? You want a lot of storage, right? You want to keep a lot of photos and videos, right? So you want a lot of storage. So if a phone has 3, what are the units that the phone manufacturer tells you? Oh, GB, like that? Or do they write this? Which one? This or this? Okay. What does this mean now? It has 3 times 10 to the power of 9. This giga over here. See the giga? The G means 10 to the power of 9. The 3 is simply 3 lah. And then the B over here is BYTES. Okay? So this tells me that I have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 bytes. In your phone. Is that a lot? Yeah, it's a lot. Oh, little. So what do we do if we need more storage? Buy another phone or buy a memory card, right? So memory card, what size do you want to buy? You want to buy 2 megabyte? 2 megabyte?
1 terabyte.
Okay, so you see, you are actually all very familiar with these terms already. Do you want a 8 megabyte phone or do you want a 2 megabyte phone? Okay, let me try again. Do you want an 8 megabyte phone or do you want an 8 gigabyte phone? Giga, because giga is bigger than mega. Okay, then how much is a mega? Let's see whether it is covered over here, okay? Oh, mega. Next one. Mega, 10 to the power of 6. So this over here is giga. Okay, so next one we're going to talk about will be mega. Again, let me use the same context. 10 to the power of 6 is actually 1000000. Is this number familiar to you?
Yes.
What do we call it? 1 million. Okay, so one way you can help yourself remember will be 1 million. Million starts with an M for mega. That's how you can use it to help you remember. Okay, so since there are 6 zeros, it will be 10 to the power of 6. And we all know, without using mathematics, without using physics, we all know that a megabyte is going to be smaller than a gigabyte. How much smaller? How much smaller?
100,000.
How many times different?
1.1.
No, stop guessing. Look at it mathematically. Yes, it is 1,000 times different. Okay, so if I have a 8 gigabyte phone, it is the same as 1,000 8 megabyte phone. Do you see the difference? Do you understand? Okay, there's a difference of 1,000. So in this case, we will use capital M. Okay, if you look at your phone, your photos that you have taken, so look at the details, they will tell you the size of the picture, right? And the size usually will be megabytes. Okay, you will see that your photo is approximately maybe 20 megabytes. Yeah, small. That's why your phone can store a lot of photos. Okay. So let's go smaller this time. Kilo. That is something that all of you should be very familiar with. Kilo. You've seen it in kilogram, you've seen it in kilometers, right? Kilo. So every time you see the kilo, it simply means 10 to the power of 3. That's all that it means, which is actually 1,000. Alright? And the last one, we've got milli. Milli is 10 to the power minus 3. You'll learn it in mathematics, but let me just rewrite it for you. 10 to the power minus 3 is actually the same as 1 over 1,000. Your mathematics teacher will teach you why it is like that. But for now, for physics, you can choose to write it either like this, 10 to the power minus 3, or you can write 1 over 1,000. Okay, and this means milli. Any questions for this page? Do we need to memorize all this? Yes, you do. Is there any that you have already memorized? Gigabyte. Why would you memorize gigabyte already? Oh, okay. So yeah. You can tell me that you are familiar with giga, but do you know how many zeros are there?
Yes.
Now you know there are 9. Okay. So once you remember giga, that is 9 zeros. You can also do mega, right? Because mega starts with M, which is the same as million. So how many zeros? 6. You've already memorized that already, so don't need to memorize that one. Kilo. Are you sure you need to memorize? Because it is already in your head, right? Since primary school. And milli is just 1 over 1,000. So, by the end of this lesson, would you have already memorized everything? You should have, right? Because there's only one that is very different, which is giga, 10 to the power 9. Okay, and then the symbol as shown. Now, if we go smaller, we've got things like micro. Okay, micro. How small is this number? 10 to the power of minus 6. You know, 10 to the power of minus 3 is actually 1 over 1,000, right? 1 over 1,000 is a small number, isn't it? Yeah, you're right. 10 to the power of negative 6 is actually 1 over 1 million. Is that very tiny?
Yes.
Yes, it is. Okay, so we've got 10 to the power of minus 6 is actually the same as 1 over 2, 3, 1, 2, 3. Okay, this is 1 over 1 million. This is very small. Have you heard of this word before? Micro.
Yes.
When did you hear of it? Microorganisms, microscopes. What else? Micro SIM card. I was waiting for that. Because you all like to talk about phones, right? What is the difference between a micro SIM card and a normal SIM card?
It's smaller.
Smaller. Yeah, okay. So in the past, SIM cards look like, for example, this size. Example only, I'm just drawing only. Then technology progressed. The phones, they needed more space, right? You want to store more things inside. So some things needed to be smaller. Then the rest, actually the SIM card don't need to be so big. Let's make a smaller SIM card. They call it a micro SIM card. Okay, then after that what happened? Nano. They make it even smaller. Nano. Yeah. Okay. Yeah. So you see, over here, you are familiar with all these terms. You see the word micro, you see the word nano? Nano. 10 to the power of negative 9. So nano is actually 1 over, yeah, you're right, 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's nano. Right? Okay, anything you need me to clarify on this table? Nothing? Okay, then I would like you to read this value out. This is, what is this? 98 what? 98 what? Millimeters. What is this millimeters? Did I write mm? No, if I write mm, you look like this. 98 millimeters. What exactly is this? Look at the symbol. Which one does it look like? Mega. Mega will look like this. Yes? Micro. Look at micro properly. Look at micro. Do you know how to write micro?
No.
Okay, so it goes like this. Okay, it's like a U. It's like a U, but you just increase this one.
Wow.
Okay, that is micro. The second last one over here, micro. So check that you have written it correctly. Everything else is just English letters. This one over here is not an English letter, so you need to know how to write it. Okay? I don't know whether it's Greek or not. It's probably Greek. 10? Okay, moving on. Conversion. Okay, this one, I'll let you check. We use joules to measure energy, and 683,000 joules. That is a large number. Can you imagine if you have to keep writing so many zeros? It's troublesome. So sometimes we want to convert it to kilojoules. How do you convert from, for example, grams to kilograms, for example? Divide by 1,000. How do you convert from meters to kilometers? What do you do? Divide by 1,000. How do you convert from joules to kilojoules? Divide by 1,000. Same thing. Why is it that we are dividing by 1,000? Because earlier on, when we talk about kilo, it is 10 to the power of 3, right? Which is 1,000. So if you want to go from kilogram to gram, what do you do? Kilogram to gram, what do you do? Multiply. Kilogram to gram. 1 kilogram to grams will be multiplied by 1,000, right? If you go the other way around, you'll be dividing. Okay? So same principle for all of these. How do we read this? 8 milliseconds. How much is a milli? How much is a milli? Milli is big or small? It's small, right? How small is it? It's 1 divided by? No. Not 10. Milli, come on. Divided by 1,000. You are supposed to have memorized this. So if I want to work out part D, 8 milliseconds, this is my working, equals to 8 times, now milli, I go back to my table. Oh, milli is over here. This is equals to 1 over 1000. So 8 milliseconds, 8 times 1 over 1000 of a second. So this gives me 8 over 1000, which is the same as 0.008 seconds. Everything can be worked out this way. How many minutes in 1 hour? How many seconds in 1 minute? Okay, good. Now we come to the reading of vernier calipers. Is the reading of vernier calipers difficult? No, it is not. We just need to follow a few steps. Remember how our eyes move? Where do we start from? Where do our eyes start from? Bottom, okay. So let's try with this example. My eyes at the bottom, at the vernier scale, what should I be looking out for? Okay, 0. I see 0 already, then where do my eyes go? Where do my eyes go? Up or down? Up. Okay, what do I look for? Before, yes. So what is this value? 1. Do I write down 1?
Yes.
Or do I write down 1 point something? 1 point what? 1.0. And then my eyes go back down. What do I look for? Straight line. Where is it? This one? Okay, so from here I go up 1.04. What's the answer? 1.04. Do you have that? Okay, so answer 1.04 cm. Take note of the units. When you read from the vernier calipers, your answer must always be 2 dp in cm. Vernier calipers, you do not get the right VC, you have to spell it out. Vernier calipers, the answer will always be 2 dp for cm. Always, always, always. Next one. Okay, I show you the answer already. Okay, so look for the 0 at the bottom. Then your eyes go back to the top. The marking before it, this is 13.4. Okay, so let's write it down, 13.4. So it's supposed to be 2 dp, right? I'm missing one number. My eyes go back down. What do I look out for? Straight line. Where is it? Oh, 5. Yes, it is over here. So 13.45 cm. Is it difficult? No, it's not difficult. It's simple, right? But I tell you, many of your seniors, right, they still don't know how to do it because they refuse to learn. They think it's very difficult. They refuse to learn. But in Sec 1, this is the first topic. Very easy for us to learn and remember as long as you practice. So don't lose this skill. Next one. What do we have? What is the value? 6 point. Okay, so we are interested in this one, right? So 6.8. Then look for over here. So 9 cm. Okay? So it seems like most of you know how to read it. I am sure there's still somebody who doesn't know how to read it. And if that person is you, you should be worried. I'm sure this will be tested. Okay, next. Here we have vernier calipers when they are fully closed. When vernier calipers are fully closed, it is the same as the weighing scale. You remember the Durian salad? When we don't have the durian, what is it supposed to point to? 0. When vernier calipers is fully closed, is it measuring anything? It shouldn't be measuring anything. So what should it read? It should read 0. How does a vernier calipers read 0? Zeros all coincide, right? By right, the 0 on the top, the 0 at the bottom must form one straight line. Let's see if this is the case. Okay, so it is fully closed, Oh, okay, looks like there's a problem. Are the zeros in one straight line? No. Okay, where is the 0 at the bottom? Is it to the left or to the right? It is to the right. So what does that imply? Yeah, it means that it is reading too much or too little? Too much, yeah. So there is too much. It is positive. If If it's too much, it is positive. If it is too little, it's negative. Okay? So I know, yeah, straight away. This must be a positive zero error, so I put a plus. Okay, it's giving me too much. How much is too much in this case? How much extra are they giving me? So all that needs to be done is to read the vernier calipers. Okay, same approach. Look at the bottom, 0. Look at the top, again we have 0. So what should I write? 0.0. Okay, excellent. Now I need 2 dp, right? What is the last number? 9. I look for where it coincides. Oh yeah, looks like you're right. This is a 9 over here. cm. Okay, so this error is 0.09 cm. Positive error. Okay? Questions? Must. Yes, you must put a plus. You must. Must. Okay, next. Is it going to be still a positive zero error? What is it over here? Is it positive?
Yes.
Yeah, it looks like it's positive. Okay, how much is it now? Positive 0.02 cm. Okay, this which error is bigger?
The first one.
A or B?
A.
A has a bigger error. So if you have to choose one to use, right? B doesn't look as spoiled lah. Okay, but we all know how to handle zero errors anyway, and we will do that later on. Okay, so 0.02 positive 0.02 cm. Okay, moving on. After we have done positive zero error, I think another case. Now, positive or negative zero error?
Negative.
Negative. How do you know?
It's on the left. It's on the left.
What is on the left? The vernier scale. Yes, use the correct terms. The vernier scale. The part at the bottom that is moving is called the vernier scale. The vernier scale is to the left. That's why I know this has to be a negative zero error. Put on the negative sign. So how much is it? Should I be reading it as usual? No, you're right. How should I read a negative zero error? It should be from the back. I count from the back. Okay? So I count from the back where they coincide. 1, 2, 3, 4. Okay? So this is negative 0.04 cm. Okay? Negative 0.04 cm. And I'm sure you can do the next one yourself. Let's see. Okay, what do you think is the answer? For those of you who have not tried, you try it now. Tell me what's the answer.
0.06.
You have tried, right? Oh, you haven't? Okay, so it is a negative error. Put on the negative. In this case, again, it will be 0.0. Counting from the back. 1, 2, 3, 4, 5, 6. Stop there because it coincides. And the units, you cannot just write negative 0.06. You must have cm. Okay? This skill is extremely important. I cannot overemphasize it. It is extremely important. Because you can be sure we won't just test you like that. What is likely going to happen is that we will test you on the corrected readings. Okay, so here I have got 1, 2, 3, 4, 5, 6. I got 6 vernier calipers, all of which are not perfect. They're not perfect. How do I know they're not perfect? They all have errors. Okay, when I close them fully, they all don't give me 0. They give me nonsense like this. 0.03, 0.01, negative, whatever. So I have no choice. That's the only one I have. So I use it to measure something and I read. Okay, let's say I use vernier calipers number 8. It has a positive zero error of 0.03 cm. That means without measuring anything, it is already telling me, the size of the length of this nothing over here is 0.03. Does that make sense? Alright, you can't measure nothing and tell me it is 0.03. It's meant to be 0. However, it's telling me there is 0.03 cm. Never mind. I use it to measure my eraser. It is 2.43 cm. Do you think that value is correct? 2.43. It's not correct. What should I do? I'll minus away the extra, okay? So look at the working carefully. I minus away the extra. 2.43 minus 0.03 and the answer is 2.40. Okay. in primary school, your mathematics teacher will tell you, should you leave your answer as 2.40?
No.
What will your primary school teacher tell you? 2.4 cm, right? Because they're the same, isn't it?
Yes.
Okay, now you are in secondary school already. You are doing physics. Can you imagine what happens if you measure your eraser with your vernier calipers? Then you, after you use your vernier calipers, you corrected the error, and then your answer is 2.4 cm. Okay? Now, another person comes along. Mr. Wong comes along. Oh, the eraser is 2.4 cm. You must have used a
Meter.
meter rule measure. Why?
Because it's only one decimal.
Because it's only 1 dp. Okay, but you use a meter rule?
No.
No, you didn't. What did you use? Vernier calipers. So, should you be leaving your answer like this? No, you should leave the answer like this. So that when I come along, I see, oh, 2.40, this student used a vernier calipers. Understand? Okay, so 2.40. Now, next one. Positive error of 0.01 cm. Observed reading 13.87. So to correct the reading, we always take the observed minus the error. So the first three shouldn't be a problem to you. Check your work. Do your corrections if any. Notice that for the first three, we always simply subtract, and our final answer will still be in 2 dp. You must give your units. Okay? Now for the fourth one. The fourth, fifth, and sixth questions, they are all negative, right? Since they are all negative, it means they are negative zero errors. So one way is simply to take 3.60 plus 0.02. You take 8.32 plus 0.05. You take 2.36 plus 0.08. You will get the correct answer. Alternatively, if you are like me, I remember it this way. The correct reading is always taking the observed minus the zero error. I don't care whether the zero error is positive or negative. I just minus it. So look, this is what I've done. This is the observed reading, 7.69. I minus 0.08. This is 3.60, the observed reading. I minus how much? What did I minus?
0.02.
Did I minus 0.02? No. What did I minus? I minus negative 0.02. 8.32 minus negative 0.05. I just copy down whatever it is over there. Okay? 2.36 minus negative 0.08. Now it becomes mathematics. Minus negative number is the same as plus. This portion over here is the same as plus. Every time you have a minus, negative is the plus. That's it. Okay? So our answers will obviously be the same as if we simply use 3.60 plus 0.02. Use your calculator to verify all this. Okay? Any questions? Okay, moving on. Precision. Instrument. First one. Tape measure. Oh, what's a tape measure? Have you seen a tape measure being used? When?
Construction site.
Construction site. Okay. Okay. Any more? Usually those very flimsy one, people roll it up. IKEA, yes, IKEA, yes. Now we buy furniture, right? IKEA. They have a lot of those white strips hanging for you to go and take, right? Do you go and take them? For what? You bring home, then you bring it home to learn physics. Okay, bring it home, go and measure things. It should have the same precision as our meter rule. It can measure up to 1 mm. Cannot go smaller than that already. Look at a ruler. Can you go smaller than 1 mm? Cannot. It is the same as the tape measure. Okay. So besides that, this can also be found in it's used by tailors, right? Tailors, when they want to make clothes, measure your shoulder, measure your waist, everything. So same. These two are the same, including the same as your ruler. Vernier calipers, 0.01 cm. When I say all, I actually mean they are equal, okay? Which is equal to, they're all equal. 0.01 cm is the same as 0.1 mm. Can I just include one more instrument since we have this table? Please copy this down. Micrometer screw gauge. Micrometer screw gauge. Okay, so this micrometer screw gauge is even more powerful. It's even more powerful. It goes to 0.001 cm or do you know how many mm is that? 0.01 mm. Okay? Okay, next. We are coming to the end already. Find the volume of the stone. Oh, this looks like a primary school maths question, right? A science. Okay. So what should we do to find the volume? Minus. How about this? If I present my answer this way. 31.7 minus 20.4 equals to, how much is this? 11.3. Okay, finish. How is this presentation? Why is it wrong? Huh? No cm? Oh, okay. How about this? Right or wrong? Why wrong? Oh, there's a cube. Okay, how about this now? Is it right or wrong? Why wrong? What do you mean? Oh, you must write the cubic centimeter here, is it? Okay. How about it now? Is it right or wrong? Right or wrong? Who thinks we can still improve on it? No. Yes? Any suggestion? Huh? It's perfect. Hey, actually, if I look at this, I don't know what you're doing, no? Yes. Huh? Oh, you mean you want to write down a statement over here, volume of stone equals to, is it? Okay. Is this, are these three words important? Volume of stone? Not important? Important or not important? Does it help the marker understand what you are doing? Then it's important. If it helps me understand, then it's important. If you throw me a bunch of numbers, to me it's mathematics, I don't know what you're doing. Okay? Subsequently, you will see problems that require more steps. When you have more steps and you give me something plus something or something times something, wow, many lines of steps, I don't know what you're doing. So it is important that you write down what you are calculating. So in this case, you can simply write volume equals to something minus something and get the answer with the units. Okay, if you want to be more precise, you can write volume of stone. Okay? So please make this a habit, including for your mathematics. Always have this part to help the marker know what you are doing. So volume, 11.3 cubic centimeters. Okay, next, a simple pendulum. It moves, the time taken from A to C is 0.6. 0.6 seconds. Now, when it moved from A to C, did it complete one full cycle? Must come back, right? So it must go back to A. So how long do you think it will take to go back to A? To go back to A. And again, another 0.6. So total will be 1.2 seconds. And what is the name of this time? It's known as the period. So 0.6 times 2, you get 1.2 seconds. Easy, huh? Okay, so this is the answer, 1.2 seconds. Now, if I want to make what's this? 25 or 2.5? 2.5 oscillations. Okay, it's not 25, huh? So 2.5 oscillations. You will take 1.2, that is the time for 1, multiplied by 2.5. As simple as that. Okay? Can you tell me the time taken for 10 oscillations? Yes, you can. Yes, you can use your calculator. Now, can you tell me what is the time taken for 10 oscillations? Okay, how much is that? 1.2 times 10. 12 seconds. Very good. Okay, now the student lengthens the pendulum. So he makes the line longer. He makes the string longer. Would that have an effect? What is the, did I show you the effect?
Yes.
How did I show you the effect? What did I use? I used the fan. No, I didn't use the fan. Remember I showed you a string the last lesson, and then I tied something at the bottom, then I let it swing. And then this is like the grandfather clock, right? You see in the movies, in cartoons, just swinging and swinging. It helps to keep time. Yes. Yeah. Then they use the pendulum, and the length of the pendulum is very important because it determines the period. What happens if the length is very long? Does it take a longer time or a shorter time to finish one cycle? Think about it. If it is longer, and then I let it swing, does it take a longer time or a shorter time? Longer time, you're right. You can always experiment this by yourself at home. Just find a piece of string, tie something to it, go and measure, and then you lengthen the string or you shorten the string, and you see how the time changes. Okay? One easy way to remember is the longer the string, the longer the time. Yeah. The shorter the string, the shorter the time. And in this case, the time I'm referring to will be the period. Okay? So this student now lengthens the pendulum, measure the time taken for 20 oscillations. So the process is repeated. These are the results. So this over here is the time for, these are the times for 20 oscillations. All of them for 20 oscillations. Okay? How many times did he do the experiment? No, he did another 4 times. So total he did 5 times. Okay? Now, calculate the new period of the pendulum. This person, why is he repeating the experiment so many times? He got too much time, right? He did it so many times. Why? Make it reliable, the human reaction error becomes smaller. Okay, that is for 20 times. Make it, measure it for 20 oscillations, reduces the human reaction time error. Okay, because we divide it by 20, so it becomes very small. And then we repeat the experiment so many times because we want to remove all sorts of other random errors. Okay, so we find first the average for 20 oscillations. The average for 20 oscillations. So we add all of them up and then we divide it by 5. And we see that, it is actually 35.456 seconds. This is the time, this is the average time for 20 oscillations. Okay? Then I want the period. The period is the time taken for just one oscillation. So now that I have the average, which is 35.456, I use this to divide it by 20 to get the new period, which is approximately 1.77 seconds. Okay? Is there any other way to do this? Is there any other way to find the period? If you are given this question, what will you do to find the period? This is one way to do it. How about I take this number, I divide by 20. I get an answer. This number divided by 20, another answer. Divide by 20, divide by 20, divide by 20. There are 5 answers, right? I find the average. Will that work?
Yes.
Yeah, it will work. No, it's the same. Mathematically, it's going to be the same. Okay, you can go and try it out yourself. So in this case, the new period is 1.77 seconds. Do you think there's something wrong with this answer?
Yes.
What's wrong with it? Estimation is not a problem over here. Okay, can you compare what was the original period? What was the original period? 1.2 seconds. Now what happened? What's the period now? 1.77. Is it longer or shorter? Longer. So is that correct? Does it make sense? When I lengthen the pendulum, the time taken will be longer. So this makes sense. Okay? If the question changed or the student shortened the pendulum, what do we expect this number to become? Smaller than? Yeah, the first one, which was 1.2. You understand how it works now? Did they say anything about the mass of the pendulum? They didn't. Do you remember what I said about the mass of the pendulum? Does it affect the oscillation, the time? No, it doesn't affect. And that is where we come to the last page. When we repeat the experiment with a shorter pendulum, the string becomes shorter, the period will decrease. Okay, period referring to the time taken for one oscillation. Right? part 2. This is where many students have the misconception, they have the wrong idea. They think that if I make it heavier, then the time taken will be either shorter or longer. They think. But it doesn't work that way. Doesn't matter what the weight is. So in the next one, we use a heavier bob. There's no change. Doesn't affect at all. This is a common mistake that students will make. And it is again a very popular question because many students like to make this mistake. So we see who are those from this batch who will make this mistake. Okay? Will you make the mistake?
No.
No, please don't make the mistake.
Yes.
So heavier bob, no change. Is that part 3? Smaller angle of displacement. Okay, sounds like very big words. It basically means the angle, they move it to the side. So the pendulum, we move it to the side and then we release, right? So it swings and swings and swings. If I don't pull it so much, I pull a little bit only. How does the period change? Shorter? Longer? You'll be surprised that actually no change again.
What
Yeah.
is the word?
Okay. Notice that when we talk about the pendulum experiment, we always say use a small angle of displacement. We always pull it to the side by a little bit only. Okay, because it is not going to change in this case. Okay, we take it that there is no change when you use a smaller angle of displacement. The period will still be the same. Okay, so these are the things that you need to know and or memorize. Okay, I will stop the recording.